So the third competencies on rational function is determining the asymptotes. Determine the vertical, horizontal, and slant asymptotes of irrational. So what is an asymptote? An asymptote is a line that your graph will closely reach that line, but it will not intersect or cross that particular line. So we have what we call the vertical asymptote. So you have the definition of the vertical asymptote. It's a line x equals a. Again, it's a line x equals a of the graph of the function f of x either increases or decreases without bound as x approaches a from either left or right. So you have the blue broken lines as the vertical asymptote. So as x approaches a from the right, it approaches to f of x approaches to positive infinity. As x approaches a from the left, so it approaches positive infinity. A from the right, a from the right, it approaches negative infinity. And then a from the left approaches negative infinity. So how do we look for the vertical asymptote? So for a rational function, f of x equals p of x over q of x. P of x and q of x are polynomials with no common factors. No common factors. So again, no common factors other than the constant. If a is a zero of the denominator, then the line equals a is a vertical asymptote for the graph of the function. Again, no common factors other than the constant. A is a zero denominator. Then you have x equals a as your vertical asymptote. So how do we determine the vertical asymptote for the graph of each of the following functions? So f of x equals 2x minus 11 all over x squared plus 2x minus 8. H of x equals x squared minus 4x all over x cubed minus x. And g of x equals x minus 2 all over x cubed minus 5x. So first, all you have to do is to factor your numerator and the denominator. So factoring, you have 2x minus 11 for the numerator and x squared plus 2x minus 8. The factors are x plus 4 times x minus 2. After you factor, all you have to do is to equate the denominator to 0. So you have x minus 4, rather x plus 4 equals 0, and x minus 2 equals 0. That gives you the two vertical lines. So you have x equals negative 4 and then x equals 2 as your vertical asymptote. So I am just showing you the graph of the function so that you will have an idea on how your vertical asymptote will look like. So in this particular case, you have two vertical asymptote. So this is your, remember in the representation of function, when you have the point of discontinuity between 2 points. So the vertical line serves as the point of discontinuity. So you have here x equals -4 and x equals 2. So you here again you have two vertical asymptotes. So simply equate the denominator to 0, check for common factors. Next. So the given function is x squared minus 4x over x cubed minus x. Factoring the numerator and the denominator, you'll have x times x minus 4 all over x times x squared minus 1. The denominator can still be factored to x times x plus 1 times x minus 1. So take a look at your denominator. Take a look at the factored form. So what can you see? What do you observe with the factored form? So here we have the common factor x. So that means the common factor x, you have a common factor. So first you have to cancel out the common factors before you look for the vertical asymptote. So in this particular case, you have you have the graph of the function. So this is the graph of the function. So what do you observe with the graph of the function? So here, even if we have three factors in the denominator, we only have x equals +1 and x equals -1. Again, we equate the factors. So you have x plus 1 equals 0. You have x equals -1. And x minus 1 equals 0. You have x equals +1. So that is the equation of your vertical asymptote. So x, this broken line. So x equals -1 and x equals 1. But what do you observe with the graph? Take a look at your graph. You have this hole in the graph. So meaning, why is it we have a hole in the graph? Remember the factor that we cancel. So that means x is equal to 0. So what is the point of that hole? So all we have to do is to substitute in the given function 0. So you will have 0 minus 4 all over 0 squared minus 1. So you have -4 over -1. So you have 4. So meaning you have a hole in your graph at 0, 4. That's why you have this hole. So this happens when you have a common factor in your numerator and the denominator. And then with that value, x equals 0, substituted it with your function, then you'll get the value, the y value, the point that is the coordinate of your hole. Okay, so let's proceed. Let me clear my annotation. So this time, you have another function given, g of x equals x minus 2 over x cubed minus 5x. So we factor, then equate it to 0, equate the denominator to 0, so that we can get the vertical asymptote. So this is the graph of your given function. So if you can see, we have how many asymptotes? vertical asymptotes. We have three. So that is from x equals 0, and then x squared minus 5 equals 0, which is x squared equals positive 5. So you have x equals positive negative the square root of 5. So you have asymptote x equals 0, vertical asymptote x equals 0. So this one, this line, the axis itself, and then equals x equals negative square root of 5, approximately negative 2.2, and square root of 5. So that's our vertical asymptote. Okay, so we're done with the vertical asymptote. Next asymptote is a horizontal asymptote. So horizontal asymptote definition is the line y equals b of the graph of the function if f of x approaches b as x increases or decreases without back bound. So we have the following examples of our asymptote, horizontal asymptote this time. Okay, so you have here y equals b. So as x approaches positive infinity, x approaches positive infinity. Here, x approaches positive infinity. So observe, a horizontal asymptote steers a function as x gets large. Therefore, when x is not large, the function may cross the asymptote. So if vertical asymptote cannot be intersect by the line of your graphs, horizontal asymptote may be intersected by the line of your graph. For vertical asymptote, it cannot intersect your vertical asymptote. Horizontal asymptote possible. So how do we look for, or how do we determine the horizontal asymptotes? So we have three possible cases. The first case is um, the degree of the numerator is greater than the degree of the denominator. Here, um, n and m represents the degree of your numerator and the denominator. So if the degree of the numerator is less than the degree of the denominator, you have y equals 0 as your horizontal asymptote. If the degree of the numerator are equal, you have to get the ratio of the leading coefficient of your asymptote. And if it is greater than, there is no horizontal asymptote. So again, we have three possible cases comparing the degree of the numerator and the denominator. If it is less than, y equals 0. If it is equal, the ratio of the leading coefficient. And if it is greater than, there is no horizontal asymptote. Okay, so let's take a look at the following. Let's identify the degree of the numerator and the denominator. So we let n be the degree of the numerator and m the degree of the denominator. So let's identify the degree. So we have for the numerator, n is equal to 1. And then denominator, the degree is 2. So here, 1 and 2. So comparing the two, rather n is less than m. So what is our horizontal asymptote? So horizontal asymptote, it's less than, so y equals 0. Second, n is 2, degree of the numerator is 2, degree of the denominator is also 2. So what's the relationship? It's equal. So the horizontal asymptote is the ratio of the coefficient. So you have y equals 8 over 4. So it's 2. Horizontal asymptote is y equals to 2. Third, you have n equals 3, m equals 2. So n is greater than m. So meaning we have no horizontal asymptote. So that's the horizontal asymptote. Okay. We have another asymptote which we call slant asymptote or oblique asymptote. So when do we have a slant asymptote? So definition, let f be a rational function given by f of x equals n of x over d of x, where n of x and d of x are polynomials, and the degree of n of x is 1 more than the degree of d of x, or the degree of your numerator is 1 more than the degree of your denominator, you have a slant asymptote. So how do we look for the slant asymptote? So here, all you have to do is to divide n of x by d of x. And then the line y equals mx plus b is the slant asymptote of your rational function. So let's have an example. Oh, here. So the instruction is find all the asymptotes. So first, let's look for all the asymptotes. So let's have this in factored form. So you have x minus 2 in your denominator. Numerator is 2x, x, 1, 1, plus 1 minus 1, negative x, positive 2x. So that means there's no factor in your numerator. You cannot factor the numerator. Okay? So this is already our function. So let's identify vertical asymptote. What is our vertical asymptote? So vertical asymptote, we equate the denominator to 0. So you have x equals horizontal asymptote. So take a look at the degree. This is 2 and this is 1. So it's greater. So we don't have a horizontal asymptote. But take a look at the degree of the numerator and the denominator. Subtracting 2 minus 1. So we have a slant asymptote or an oblique asymptote. So how do we get the slant asymptote or oblique asymptote? So we have to divide 2x squared minus 3x minus 1 by x minus 2. So recall how to divide. So this is 2. So 2x, rather 2x. So 2x squared minus 4x. So plus minus x minus 1. So plus 1. So x minus 2, 1. So no need to take note of the remainder, just the form of y equals mx plus b. So that is your slant asymptote. So again, to get the slant asymptote, the degree of the numerator is 1 less than the degree of your denominator. So here 2 minus 1. So vertical asymptote again is x equals 2. Non-slant asymptote y equals 2x plus 1. Again, We have that by dividing the numerator by the denominator. So you have the graph. So again, this is your slant asymptote, this line. So what is that line? That is the line for y equals 2x plus 1. Okay. Okay. So we are now on, I think that's the last slide, the slant asymptote. So that's it for all the asymptotes. So again, vertical asymptote, you have to equate the denominator, each factor of your denominator to 0 after canceling or uh, canceling the common factor. For the horizontal asymptote, you have to compare the degree of your numerator and the denominator. And also, for the slant asymptote, compare the degree of the numerator and the denominator. So you can only have an at most uh, one horizontal asymptote or slant asymptote, but you cannot have both horizontal and slant asymptote. So that's it for the asymptote.